Good evening, Alternative Energy. This is John Jones, and I am presenting my wind turbine project. For this project, I decided to build a DIY wind turbine. I was inspired by an article I found on Instructables.com called How I Built an Electricity Producing Wind Turbine by M. Davis 19. Now, M. Davis 19 constructed his wind turbine for use in a desert when he goes camping. I decided to construct mine just for outdoor use, hopefully, because I live in the Midwest, and so it's geographically appropriate to try to harness the wind here. Although, in my state of Illinois, most of the wind turbines are in the middle of the state or further north. I am in the south, so we don't have a lot of wind turbines around here. I was interested in constructing the turbine using natural materials if possible. So at first I looked for bamboo. And although I found plenty of bamboo for sale, unfortunately it wasn't the right size for what I intended. I wanted thicker rods of bamboo to use for the base that you see I used PVC conduit for. And I also wanted some thicker strips of bamboo that I could carve into fan blades. Unfortunately, what I found was mostly intended for decorative use, so it was rather small. Because of that, I shifted my attention from trying to source natural materials to trying to source recycled materials or materials that were being discarded. I purchased a few small motors, some cheap fan blades, and some tools because most of my tools are intended for computer repair or assembly. For the rest of the project, I did succeed in finding materials that other people were discarding. Now, the first thing I learned about wind turbines was that the rotors drive a system of gears, which in turn drive the shaft of a generator. I read a few articles about gear reductions and gear ratios and filled in some gaps in my physics knowledge. That information stuck with me, and so my original design was to use gear reduction to take a relatively low number of revolutions per minute, say 90 to 120, and increase it to hundreds, if not thousands of revolutions per minute to maximize the power output of my motors. As an example, here's the original motor that I purchased. It's a 24 volt DC motor that has a maximal output of 350 watts, and the RPM is listed at 2700, which is a pretty ambitious rate. When I turn it with my hands, I can see that it's a little bit sticky. There's a bit of friction to overcome. Now, I sourced the rods and gears in the project from 3 devices that a local printer vendor was discarding. It's possible that those devices could have been refurbished, but this particular vendor manufactures and sells and leases new equipment. So they allowed me to take parts from these devices that they chose not to refurbish and resell. As you can see, there's this rod here that I have the rotor affixed to. That is from a Fujitsu scanner. And then these gears here, as well as this spacer behind one of the gears, those were all from a Xerox multifunction printer. So I sourced parts from a Xerox Workcenter 5325, an HP LaserJet 4250, and a few Fujitsu FI 6130 scanners. In those devices, I found several stepper motors, a dozen or more metal rods, and even more plastic gears. Originally, I assembled a gear reduction system using several plastic spur gears that featured 2 rings of teeth. I used the larger ring to drive the next spur gear's smaller ring. Here's an example of that. So this would have been an idle gear really. It would have connected to a driver gear to rotate it, and I connected them larger gear to smaller, larger to smaller, in order to increase the revolutions per minute of the driven gear. Now, in theory, that's the right idea, but Even though I was able to increase the revolutions per minute of the driven gear, I couldn't get the rotor to remain in motion. So I concluded that the force provided by the air currents was not sufficient to overcome the force of friction that I needed to set the gear system into motion and sustain that motion. I tried a few more configurations before I settled on larger gears with less drastic ratios and fewer gears overall. As you could see from that prototype, the gears there are very small, so alignment was a bit challenging. In my final result, I used gears that are noticeably larger, and that made it easier to align them and keep them rotating without falling out of sync. You can also see that there are a lot fewer gears there, so I had less friction to overcome in the final result. Now, that allowed me to affix two small motors that spin reasonably well. Of course, they don't produce a lot of electricity. Their maximum output would be 12 volts apiece, but the manufacturer describes that as occurring at something like 7,200 revolutions per minute, which I haven't been able to approach. So overall, the fan blades were purchased. Some of the PVC was purchased. I already had some twine. Let's see here. But the most fun part, the gear system, was recycled. So now I'm going to demonstrate the operation of this unit and then talk about what could be improved. So we'll face it toward the fan. Now, as you can see, this turbine is not reacting to the fan when it's on low. I can even angle it a little bit differently, and that doesn't make a difference. So let's turn it up to medium. Still nothing. But when the fan is on high, we do get some rotation. And with that rotation, we get movement of the gears. As you can see, the gears are spinning these small motors. And I have 14 gauge wire going through the PVC conduit, down where I connected it to some alligator clips for testing. So, now I'm going to hook up my trusty voltmeter and see how we do. Per the operator instructions, I'm going to start at the 200 and then work my way down to more acute measurements. So right now it looks like it's about 0.6 of a volt. It's actually higher than it was before. So to get a more accurate reading, I'm going to go for a smaller volt range, looking at 20 direct current. can see it, but right now we're reading about 0.8, 8/10 of a volt. Oh, lost it for a moment. Okay, so we're holding steady at 8/10. Clearly, I am not ready to go off grid. So let's go over some EBIs, or even better ifs. If I were to do this project again, I would do more research about types of motors. Some of them are able to generate more electricity with fewer rotations of the generating shaft, so that would make them more robust, certainly more robust than these two. I am pleased with the approach of sourcing materials that were destined for a garbage pile, but I'm fairly certain that these plastic gears are better suited to printers and scanners than they are to wind turbines. Real wind turbines use specialized lubricants that protect the parts, and of course they have metal gears in them and other components that might require protection from rust in addition to a reduction in friction. So I think the right kind of lubricant would go a long way in improving performance, especially with the right materials. Now, one of the awkward things about this construction is that basically it uses PVC conduit, connecting to PVC conduit on a hex bolt there, and an identical configuration over here. The problem with that is that I didn't really translate my mathematical understanding into engineering. When I look at it now, it's pretty obvious that I was allowing what should have been a stationary plane to rotate around a linear axis, the linear axis created by those bolts. So I did manage to correct that by stabilizing the sides. As you can see, I added additional bolts, but it was one of those mistakes where intellectually I knew that 3 non-collinear points would determine a plane, but that did not translate into my design process. So there are lots of opportunities for improvement, but I do feel as though I have a better understanding of how wind turbines function, and I do have a greater respect for people who are able to go off the grid, particularly using DIY projects. All right, thanks for listening.